All right, welcome everyone. Today we're going to dive into something called complex numbers. Now, I know that name might sound a little intense, but trust me, by the end of this, you'll see they're actually a really powerful and surprisingly simple tool. So let's figure out where they even come from. For the longest time, this question was a total roadblock in math. What is the square root of -1? It just seemed impossible, right? A total dead end. But what if it wasn't a dead end at all? What if, instead, it was a doorway into a whole new dimension of numbers? So, meet I. This is the hero of our story, the imaginary unit. Mathematicians basically just invented a solution. They said, okay, let's create a number, we'll call it I, and its one special power is that when you square it, you get -1. And just like that, the impossible wasn't impossible anymore. Okay, so where does a number like I even live? Well, it lives on what we call the complex plane. Just picture a normal graph. That horizontal line, the x-axis, that's all your regular, familiar numbers, 1, 2, -5, all of them. But that vertical line, the y-axis, that's the imaginary axis. That's where we keep track of our I's. Suddenly, we're not just stuck on a flat line anymore. We're playing in 2 dimensions. So here's the game plan for today. We're going to start with the easy stuff, addition and subtraction, then we'll get into multiplication and its one crucial new rule. After that, we'll learn a really cool conjugate trick for division, and then we'll wrap it all up in a handy toolkit. Sound good? Let's jump in.
Let's kick things off with an easy win. I'm serious. If you've ever done even a little bit of algebra, this first part is going to feel so familiar. You basically already know how to do this.
And hey, don't just take my word for it. The source material says it perfectly. The big secret here is to just treat I like you'd treat any other variable, like an x. All you have to do is combine the terms that look alike. And check this out. The comparison is just perfect. Look at the left side with algebra. You combine the x's, the 4x and the 3x, and then you combine the regular numbers, the 2 and the -1. Simple. Now look at the right. It's the exact same idea. You combine the real parts, the 4 and the 3, and then you combine the imaginary parts, the 2i and the -i. Same logic, just a different letter. All right, feeling good so far? Let's step it up just a little bit with multiplication. Now, this also starts with something you already know from algebra, distributing your terms, sometimes called FOIL. But there's one tiny little twist at the end, and it's the most important part. The process is super straightforward, really. First, you just multiply everything out, just like you normally would. And as you're doing that, keep pretending I is just a variable. But once you've done all that and combined your terms, you get to the final critical step. This is the one new piece of the whole puzzle. And boom, here it is. This is the twist. This is the one single new rule you have to learn today. Whenever you're multiplying and you end up with an I squared, you just swap it out for a -1. That's it. So I acts like a variable until it gets squared. Then it becomes a regular old number. This is the whole game right here. And that brings us to the final boss, division. Now, this is usually where people get a little worried, but there's no need to be. Because for this, we have a secret weapon, a pro move I like to call the conjugate trick. So what on earth is a complex conjugate? It's really simple. You take a complex number and you just flip the sign in the middle on the imaginary part. So the conjugate of a plus bi is just a minus bi. Now, why do we care? Well, it's kind of like a rule in math. You're not supposed to leave a square root in the bottom of a fraction. And I is just that, a square root. The conjugate is our special tool for getting rid of it. So here's the game plan. You look at the complex number on the bottom of the fraction, you find its conjugate, and then you multiply both the top and the bottom by that conjugate. And this is where the magic happens. When you do this, the i's on the bottom just vanish. They completely cancel out, leaving you with a nice, simple real number down there. It works every single time. It's an awesome trick.
So there you have it. That's the 4 basic operations. We've navigated the complex plane. We've learned the secret rules. Let's do a quick recap and put all of this into a single, powerful toolkit that you can use whenever you need it.
Okay, think of this slide as your ultimate cheat sheet. For adding and subtracting, easy, just combine like terms. For multiplication, distribute everything out, and then swap any I squareds you see for -1. And for division, use that conjugate trick to clean up the denominator. For operations, 4 simple strategies. That is literally all there is to it. We started this whole thing with a broken math rule, and it ended up opening a door to a completely new dimension. Complex numbers aren't just a math curiosity. They're absolutely essential for things like electrical engineering, quantum mechanics, all sorts of advanced stuff. So the real point is this. By learning to work in this second dimension, you've unlocked a way to describe the real world in ways that people once thought were impossible. So the only question left is, what new frontiers are you going to explore?